Actually, I've been an industrial executive for more than a decade, with some experience in the oil and gas, automotive and telco companies, in startups and turnarounds, but since 2015-16 I'm just focused on industrial IoT. And this is my colleague, technical partner from PLVision, Valeriy.
Hi everyone, so my name is Valeriy Kozlov. I'm a founder and CEO of PLVision company. So we are basically in a custom IT solution development market. So we develop custom solutions for various customers. We're very much focused on software mainly, and we, on the technical aspect, we are very narrowly niched in the computer networking and IoT world. Yeah, and we are very happy to have Fabio as a partner.
Okay, thanks, Valeriy. So today we will be looking at Enel Green Power in Brazil. This is the magnitude of just 2 of the 4 projects we are talking about, and we are seeing. Okay, great. So we are just focusing today on a pilot on this little 11 megawatt Fonte dos Ventos solar and wind integrated power station. And we will see very quickly and focusing on machine learning, AI algorithm, how this will definitely impact business with actionable outcomes. That's why I'm involved as a business partner with PLVision and Valeriy. Okay, then hopefully we will have some time for question and answer. The current situation in Brazil, they already had last year this 11 megawatt Fonte Solar operating, so we decided to have this potential pilot with them, and during this year, of the 800 megawatt they already deployed and they are full functional, free of the 4 800 megawatt solar plants. And there will be a second phase for scale and optimization of the full solar parks. But this has an enormous impact on data streaming.
Yeah, and I think this is a good point to address the very obvious and natural pain point related to building of scale systems, right? So just imagine this: if a typical 5 megawatt solar plant produces about 1 terabyte data in a week, so if we are dealing with 800 megawatt, obviously then means that we need to deal with more than 100 terabytes per week. Yes, of course there could be some differences based on particular infrastructure and particular setups, but this is the amount of data we are dealing with.
Yes, and also the kind of magnitude of sensor, 800 per each 5 megawatt will be more than 100,000 sensors involved and could be taken care of, predictive maintenance with intelligent analytics. So Valeriy,
yeah. So basically, for today's industrial IoT solution development, we see there are several multidimensional aspects of solutions, and when we see the intersection of such areas as industrial automation, Internet of Things, operation technology and information technology, convergence, the particular enterprise. We as a solution builder see a lot of focus on a particular area. So first, this is things, basically the sensors which produce the data, or some drivers, actuators which receive commands, right? Obviously, we have connectivity, data transmission, network infrastructure, which also touch the edge computing, fog computing concepts, and the data itself. And for data, we need the cloud infrastructure, we need the data acquisition, we need the particular big data.
So basically the full stack of an IoT end-to-end solution.
Basically full stack and particular platforms to cover that.
Sure. Yeah. So let's see how a typical solar plant works.
Yeah, this is a very simple slide. This is the model architecture we use in a solar area. So this is very simple. Just if we go from the bottom to the top, we go here through we start with the panels, strings, inverters, substations, power stations. Obviously, at some level we have aggregation, we have a plant controller, SCADA system, different type of them could be. And of course, then we proceed with connectivity, connection to the internet, the cloud infrastructure, and everything which could be built on top of the cloud. And obviously, when we do assessment, when we do discovery of each particular case, these are particular, knowledge we need to extract from the customer and the question we ask them.
So you can see exactly the complexity of a system working with all these devices that should be aligned together. So how we approach the project, we have an integrated and modular approach in 3 phases. We are actually in phase 1, preparing to start eventually the phase 1 of discovery and design. And this is just a kind of, let's say, gap analysis on IIoT existing capabilities, or more precisely, monitoring activities. Of course, Enel has already have some kind of monitoring, but not really already implementing AI ML algorithms to enhance the performance. And by doing that, we also had, I think, a very competitive advantage, Valeriy, because what I learned during my 20 years as an executive in the industry, that if you don't have a compelling business case to show the actual potential results or numbers, bottom line, you don't go anywhere. So by doing a business case and presenting before starting a pilot, we will hopefully get a very consistent first phase, and then at scale. Valeriy, can you comment on that?
Actually, I wanted to comment on this particular approach. I would say that the general, let's say, sense why this multi-phase approach is important and valuable is this is the way how we manage uncertainty and risk together with the customers. So in each particular stage, customer is able to understand which amount of funds they're investing, which amount of risks they're facing with, the amount of uncertainty, and the potential outcome of each phase. So once we are ready to go to the pilot, for example, pilot implementation, our main goal is to show the customers that the idea, the vision they have is possible to implement. And basically here we do not focus very much on long-term parameters, but we need to show the prototype, we need to show that it's working. And once we have this prototype, we discuss it with the customer, get the feedback. After that, we learn some lessons and move to production. And pretty often in production phase, we need actually to rework something. We need to, for just a simple example, for a pilot, it's absolutely fine to use some software as a service, existing feature-rich platform. In the production, sometimes customers they see that, okay, I don't want to go to large scale paying this subscription cost, huge subscription cost, which increase our scaling, right? So pretty often, customer want to move to the custom platform. Of course, it requires some investment, but it pays off over a long period of time.
Sure, in the midterm it pays off. Yeah. There are some trade-offs that you always have to decide. Okay, so we start, of course, by a drivable it's a customer need. So what we heard from Enel was that they want to have a really agile way to data acquisition and to get some productivity gains and efficiency during the operation and maintenance of the solar plants. Okay, so we had already an initial exchange of information data, not really as a pilot on field, but we already defined that to do that we should focus on KPI monitoring the real-time status of the solar farm, benchmarking with other best practice, especially focusing on forecast, because you know you have, for regulatory reasons, you have to guarantee a certain level of energy. Labor force optimization, of course, and last but not least, just optimization of the operation, focusing on predictive maintenance. So maintenance here is the killer application in brackets, because we know for sure that, also by the Industrial Internet Consortium, but it's a very well-known practice in the industry, manufacturing, automotive, that is a continuum. So you start by doing the basic stuff, but then when you come to predictive reliability at the enterprise level, the gains are exponential. So for someone who's accustomed to know about OEE, overall equipment efficiency, for each phase of maintenance you can see the numbers. And when you start using predictive, you can have more than 90% of OEE KPIs. That is not just, it's an actual number on case studies, okay? That, having said that, while we are on the edge of a new use case and technology, these numbers that you see here in terms of production and increase and downtime, breakdown and maintenance costs are usually applied to manufacturing, right? So there are 30 to 40 gains over reactive maintenance, but also 8 to 12 over preventive maintenance. But they are not really implemented till today to solar energy renewables operations. And this is why the predictive maintenance could be, with the easily, between brackets way, with the help of PLVision, I mean data science engineering software, extrapolate the basic algorithm and then develop specific for the vertical of renewables. And as already said, the machine learning as manufacturing Industrial Internet Consortium, we can translate these algorithms to this new industry. It's actually, Enel is also is trying to do it by himself, but it's not really an easy stuff. So, as an overview and a big picture, this is our old deep tech wave. You can see here that in a heat map, the energy utilities is pretty, let's say, blue, specifically in artificial intelligence, IoT, and sensors. So there are a lot of convergence between these technology. You can't consider one standalone with each other. And in, let's say, more specific and technical way, the new possibility that machine learning enable are in addition of normal statistical analysis that are already available nowadays for everybody, but by combining the two, the real output, the real output is that we can add use case and value to a largest scale, okay? So again, 3 top use case by McKinsey in terms of predictive maintenance, opportunity in energy on maintenance analytics and operation, where you have 2 different, let's say, driver, data richness and impact. So you got data available, of course, you need data, but they are also sensitive data that makes impact on your business. So we have all the input to translate this machine learning algorithm and get what? Get results. Because now we are focusing on production, we can also could apply machine learning on other, in R&D, on promote, on provide experience. But just in production for productivity and efficiency, there have been estimation by McKinsey that we have at least 20% production increase and from 10 to 20 EBIT improvement, so bottom line. So when I talk to CEOs and board lines, we talk about this. So on the business case, we got this kind of discussion on any kind of project at scale, of course. Now, please, Valeriy, you can
So
comment a little bit on your
basically, a few words related to our particular expertise. So, as I mentioned, we're narrow focused on computer networking and industrial IoT, and our expertise in IoT field was growing more or less naturally, starting from our expertise in embedded systems, embedded computing, and of course, as the industry was developing, we moved toward the upper layers of connectivity, the cloud systems, and now we're investing a lot and expanding our AI, ML, and big data and analytics expertise. So we got here covered more or less traditional techniques like regressional analysis or cluster classification, as well as pretty advanced stuff like genetic algorithms, neural networks, and back it up with some particular expertise in high-performance computing platforms and pretty much of other stuff as well.
Okay, thanks, Fabio. So you know that by extrapolating these general capability and skills of PLVision, we just get down to earth on 5 different areas: plant monitoring, maximizing performance, optimize OEM, portfolio management, and forecasting generation. You can see the details here. And all these will be developed, custom developed, and analyzed first with an assessment, then a pilot, and then potentially modified, customized for a production at scale. And you just can see on your right side of the screen some suggestions, some kind of data visualization of dashboard, but in a way that it could be not only possible to see, but also eventually in some cases to react in an autonomous way. So sometimes when you implement prescriptive maintenance, you already have some action embedded in the algorithm. So that would be a kind of latest, highest goal. Again, down to the potential pilot in Fontes, you can see here that outage time minimization, actionable analytics, they already have a kind of, let's say, system implemented, basically monitoring, but that would be also an upgrade, a substantial upgrade on their operations, specifically if we think about spare parts, maintenance, logistic time, lead time in a region northeast of Brazil where distance are of a continent. So, and this for sure will increment the usability and streamline the process. The wheel here, you can see all the factors that enable this kind of new operation and results, but specifically machine learning, high performance computing that nowadays came easy, will enable that. Without having machine learning and high capacity computing, all this wouldn't be possible. All would be possible at really expensive effort. Okay? More specifically, we can see here, we have, I think, time, some actual preventive and detection analysis performed by a drone with a thermal camera. This is not from us, it's already something that is, I think, in Holland. Please. real-time manner, avoiding man hours, full-time equivalent of people of maintenance and going around. You can see now an aerial view of what they really can do these drones. They are checking individual cells for malfunctioning or dirt. And you can see a goose shit. What happens? Or changing the filter, getting other information from the functioning of the panels and the efficiency. Not only on a single rack, but also on a whole sector group. This is actually solar thermal function in acquisition of the solar thermal energy. I think that you got the idea of what can be done, and to conclude a little bit the, let's say, full assessment, at the end of the day, the full integrated end-to-end IoT solution could be really focused on full stack, customized development by PLVision, or eventually on top of what they already have already as a monitoring system. Valeriy, will you please comment on the full customized solution?
Maybe too many technical details here, but anyway, this is our vision of the architecture. It's combined of two sources. First, we have some generic reference architecture for IT solution, coming from experience from previous developments from different IoT areas, and also particular understanding, particular knowledge from the business analytic point of view in solar energy. So here obviously we had to cover the most the key areas, starting from physical assets in field, and obviously the edge analytics, which sometimes could be extended to a fog concept, and also gathering important part information from base station, and obviously the gateway to ensure local operations and the data transmission to the cloud. And in the cloud we got multiple services, from basic like alerting and monitoring to more advanced like reporting, AML analysis, could be also expert for third-party analytics software and so on.
Yes, Valeriy, thanks. And these are just some samples of a real-time dashboard, not really developed for that situation, but you can see here voltage, smart meter with the kind of representation, or here more focused on localization and functioning of the plant, or here, this is just for a bus in San Francisco, but you know, you can really customize the dashboard and have a real-time situation monitoring and assessing, not only in a passive way, but mostly having eventually some action, automatic action on what is going on.
Yeah, absolutely agree. The visualization is very important, even starting from very early stage of the project, because it helps to show the customer how the solution gonna look like, and they have a chance to introduce some changes to requirements at the very beginning, at the very early stage of the collaboration.
Thanks. Okay, so
Yeah, this is
sorry.
Yeah, no, it's okay. Yeah.
Okay, so going forward to
Yeah, couple of technical aspects here. So here you see the graphs from basically from the financial market. This is just to illustrate that it is very important when you work with data. It's very important to do some pre-processing of data, to do some filtering, cleansing, like removing anomalies and things like that. This is like the part of data analytics cycle.
Yes, you just can't get all the data that coming from the solar farm. You need a cleaning process and just normalizing some peaks or anomalies in order to have better results, right?
Absolutely, and sometimes sometimes just based on experience, you don't always get the correct data. Sometimes you got some issues with the sensors, and based on experience, sometimes you just cannot fix it. You need to, because you cannot replace like the hardware stuff you already have in the field, and you need to process these issues later.
And if you don't do this, machine learning applied to a series of data that got anomalies will come out with results that you don't want to have.
Yeah, like garbage in, garbage out.
Yes. Okay, so tell us about a little bit of computing power that you need to do.
Yeah, and when we are talking about the really custom solutions, we pay special attention to some technologies which help to deal with a really large amount of data, covering file systems, platforms, and in particular the computing capabilities. So, the next slide. Actually, what we see is from experience is in some cases it is absolutely reasonable for a customer to invest into their own high performance computing platform located in the company's data center, just to avoid the sort of to avoid the subscription cost from Amazon or from other cloud providers. Yeah, and it includes like high-performance GPU systems, also particular high-performance networking systems, and use of scalable platforms for IoT solutions.
And Valeriy, you already been working in this field for more than 10 years right now, so you have some case studies that you can show us, right?
Yeah. So this is one of the stories. I like it because it is very fresh, it is very typical and very real. Right? This is a very good example of the customer who, like this medium-sized company, not a giant company, right? Medium-sized company, and they understood they have good position in their market, but at some point they understood that they need to have a vision for digital transformation, and basically they wanted to bring some monitoring and management and asset management functionalities. They need an IoT solution for that, and basically they were choosing a vendor for that, and luckily we won.
And focusing on preventive maintenance, of course.
Yeah, yes, that's correct. And on the one hand, these are typical features, right? You could see them in many systems. On the other hand, it is very important to say even such a simple features like proper alert monitoring, custom designed map visualization. It sometimes brings a lot of value improvement into the business.
And the final output would be to prevent asset outage.
Absolutely.
So, what were the challenges and the business value, Valeriy?
Yeah. So basically, when someone builds a solution like this, so basically this is like the customer is a relatively small company, but they understand that they need to invest into a custom solution which is particularly tailored for their need, and they want to avoid this subscription cost in case if you use software as a service platforms, and of course building the solution assuming some technical challenges on scalability, on security, on
data. Asset connected, of course.
Yeah, this is a requirement, and especially integration with existing systems, very important. No one wants the business or operations to be stopped for whatever reason during the deployment of the system, and even things like access system is very important. particular UI and UX approaches for usability of the interface, because the customer want to employees use this system and their clients to use this system.
And apart from the desired OpEx savings, you told me that there was also a strategic effect on the market.
Yeah.
Right?
When we are talking about business value, just to summarize the business value here, obviously the OpEx saving is very important, and end user satisfaction is very important for both clients of the company and for both employees of the company. But if we take a look a little bit wider in the situation, I would say that what they are gaining is that they stay competitive and they actually improve their position toward their competitors.
And they don't lose market share.
They don't lose market share, they have a chance to gain more market share.
Perfect. So we came to a conclusion. Hopefully, I mean, it's not exhaustive, but it's what we learned from the actual activities in industrial IoT. So it's not a hype, trust us. The potential in terms of global potential, this is a McKinsey study of June 2015. We're talking about 2 trillion economic impact, starting from 2025, in 8 years' time. For Brazil, it's just from 60 to 180 billion. And taking consideration that we are just starting to see this new technology not only in Europe, US, and Brazil, this is a really big number. As Valeriy already gave you a hint, not moving is not enough. I mean, there are always the pioneer in the situation, but at least having an open mindset and having an assessment of the opportunity that this new technology enable would, let's say, justify a budget for a pilot and then try and succeed, maybe not at the first time. So this is not really a solution that it just focuses on the architecture without machine learning as the last mile of industrial IoT. Nice slogan, but it's really the combination and the convergences of these two new technologies that make the difference. And of course, challenges. This is not as easy as you all seen during these 3 days of the Congress, how many actors, how many issues, how many responsibility, interoperability, standard, and last but not least, I mean, the talent, digital scientist, computer software engineer. I mean, there will be a shortage. There is already a shortage, and because of the needs, we will have, of course, a lot to learn and wait for these new capabilities to come mainstream. But we are already starting doing this. So that's it. I would like to know if there is any question, please. We are open to discuss. Anyone? No?
Everyone is tired, I guess.
Okay. I mean, this is the last day of the Congress. Okay, thank you very much, and hopefully see you next year. Okay?
Thank you.
Bye.
Thank you.